that says, make sure everyone's okay with that. So I hope you're okay with that. Okay, so welcome back. I'd like to first just start by showing you a couple of things I updated based on your responses from yesterday. So let me just share my screen here and show you a couple of the things I updated. So let's see here. First, I posted a lot more videos and more tasks. And so when you go to our Blackboard page and you go to the online lectures tab here, let me just slide my thing over here so I can see that. When you do that, someone just said you can't see my screen. So I think when I share my screen, it creates two versions of myself, I think. I think it creates like a talking version, like the video, and then I think it creates a screen version. And so when I share my screen, you should maybe pin the screen version, I think is the way that works. Is that correct? Yeah, Zach can see it. It looks like there's two versions. There's like my screen and there's me talking. So try to find that screen version. If you're not able to find it, you can watch this video later. It is recording. So anyway, here's the Blackboard site. When you go to online lectures on the Blackboard tab, I've put a bunch of the future ones up, and I've linked them all to the YouTube page and sort of. So basically, someone said they wanted to maybe work ahead, and so I'm trying to get enough up there ahead of time to really get things going here. And when you go to the YouTube page, you'll see that there's a lot more videos there now. I had a lot of videos recorded from previous classes, so I am recording some new videos, but most of them I'm just taking from a previous time I recorded videos, and so a lot of them are up here. Again, you already have these notes. You can just work ahead as far as you want. To that point, I also posted almost all of the future homework assignments. So almost everything's up there. I'm kind of waiting to see how far this takes us and think about what the end of the semester will look like, but this is quite a bit sort of posted ahead of time. And you can see that I put a couple due like 2 or 3 weeks out here, like the future homeworks, but just to be careful about how quick we're going, I posted a bunch that currently are just due on May 13th. So as we sort of move closer to those homework assignments, I'll move the due dates up and make them due. But anyway, there's lots out there is the point. So if people want to work ahead, you're certainly willing to do that or able to do that. I want to also mention a couple other things. So tutors, as I mentioned, are still going to be available. Let me just see, make sure I got here. Okay. Tutors are going to be available in 2 ways. So first of all, the Tutor Center is still a thing. So if you go to Fitchburg State's Tutor Center website, I don't know, this is the website here, but I just Googled Fitchburg State Tutor Center. And you can see that they are still scheduling online tutor sessions here. And so I've talked to a couple people who used this yesterday. You can basically click one of these links, like online tutoring for undergrads. Oops, there's a link thing right here. And it talks about how to make online appointments. It's still sort of like walk in terms of you can just make an appointment pretty soon ahead, I believe. And I've heard that they're able to help people. It's going to be different, obviously, right? And they're still working through how to best serve you and help you and everything like that. But the Tutor Center is available through the Tutor Center website still. The Precalc tutors, the ones that were in the evenings, are still available as well. And so if you go to WebWork or Blackboard and you go to the Google Meet, Google Hangout link tab right here, I put a Google Meet link for the tutors. And so during their normal time, so Tuesday 7 to 10:30, Wednesday 7 to 11, Thursday 7 to 10:30, the tutors are going to be at this Google Meet link, where you can it'll be just like we're doing right now. They can you can chat with them, or if you need to go to video conference, they can help you there too. They're also all receiving your homework question email. So like Wednesday night or whenever you're doing your homework, if you send an email question, it's not only just going to go to me, but it'll also go to the tutors. And so it's just hopefully getting you an answer quicker. The last thing I wanted to show you was I posted all the quizzes I would have given you if we were still doing class. So if you go to the quiz solutions folder on our Blackboard site. Here are all the quizzes we did so far. And then I posted a bunch of quizzes from past semesters. And depending on the semester, I sometimes get to different material. Sometimes I do different quizzes. And so I put a couple semesters worth of quizzes in there. This is one that has like a bunch of trig quizzes, for example, that might be helpful. And then the other one, I just happen to do a lot of quizzes this one semester. And so there's like 17 or so quizzes in here. There's quizzes for exponentials and logs and polynomials and all kinds of stuff that we'll get to later in the semester. So those are good to look at and sort of practice from for any tests. As far as tests, when you go to the course calendar tab here, first of all, you'll notice that I try to put the web work up here. What I'm sort of thinking in terms of the test is probably after we finish trig, which I believe is going to be done roughly the end of April 10th. And so we'll probably finish that homework on the 15th. I'm sort of thinking doing a test in class the week of the 20th. I'll get back to you with more details and test topics and things like that, but I'm sort of thinking about doing like a remote test similar to the way we described yesterday on the 20th. More information about that as we approach there. Okay, that's, I think, all the updates in terms of online resources. Are there questions about anything I just showed you in particular before we look at the material? Questions about material? Anything there that I just showed you that I can clarify or say again or anything about that? Okay. If you don't have questions about that stuff, can I help with some of the material? Now, I personally think the material that you're supposed to watch for today, which was graphing sine and cosine, can be pretty tricky. And it's pretty tricky, especially when you're doing it on your own without me in class sort of helping you. And so that was using like the Desmos thing that I had posted to sort of play around with sine and cosine. So a question was just asked, is all the homework for the rest of the semester on web work, or will any more be posted? There might be a couple more sections after what's already posted, but I haven't posted it yet because I'm not sure exactly what we'll do. So almost all the homework is up on web work. There might be one or two more additional sections depending on how far we get. Other questions before we keep going with the material? Keep going. Cameron's asking about page 52. We can definitely look at page 52. I will post a review and test topics and all kinds of stuff for test 2. But again, it's not until it's about a month from now, and so give me a little more time for that. But yes, I will post that stuff on Blackboard. Other questions before we look at graphing sine and cosine? Okay, let me change over to the document camera. And we can look at graphs of sine and cosine. So I know Cameron was asking about page 52. This is just the first page in the graphic notes. Would people be interested in like a quick overview of graphing sine and cosine, like a 5-minute kind of thing, or should I just jump right into Cameron's question about page 52? Okay, let me just say something quick about, Cameron said, sure, so let me say something quick about graphing sine and cosine in general. So sine, we know, are the y values on the unit circle, and cosine are the x values, right? And so that's the kind of thing that sort of we need to think about at all times when we're graphing these things, is this is the shape of sine, and it's just tracing out the y values. And then this is the shape of cosine, this one right here. Let me actually just focus in on these two pictures, since this is both of them. Right, this one's sine, this one's cosine. This one's just mapping out the y values, and this one's mapping out the x values as you traverse the unit circle. And so if you know what the x values are and the y values are around there, which we should all have a good idea of what the unit circle looks like, then graphing these things shouldn't be too terrible, right? So the y values on the unit circle start at 0, they go up to 1, they go back down to 0, they go to -1, and back to 0. Like this is just going around the unit circle one time and tracing out the y's. And then when we go around the unit circle one time and trace out the x's, it creates this bowl shape, right? The x's start at 1, they go down to 0. The x values go to -1, which would be this piece. They go back to 0, and then the x values go to 1, which would be this piece right here. So they're just tracing out the x and the y values separately. And that's what leads to these shapes. Okay, so we're sort of, and if that makes sense, I really hope it does, then that should hopefully help you think about sine and cosine. If it doesn't make sense, just know that this is the shape of sine, right? It has like a top bump and a bottom bump. And this is the shape of cosine. It kind of looks like a bowl is what I think about it as, right? Sine starts at 0, cosine starts at 1. And what we're doing on the next couple pages is we're taking these two shapes and we're transforming them the same way that we transformed anything else in the course from the transformation section. And so that's what it says on the next page. So this next page is sort of giving us the general shape of sine and cosine. Page up here. Right, so this is the general form of a sine transformation and the general form of a cosine transformation. And these are the transformations that we listed in the transformation section, right? So this is just from the transformation section. And so what I was trying to get you to do in that video and through some the Desmos activity was figure out which one of these things, A, K, B, and C, control which one of these transformations. And so that's what I was doing on the that was the sort of point of the Desmos thing. Maybe I should just kind of show that real quick.
In this equations.
I'm sorry, was that a question?
Yeah, constant value, because in the video just now you said A, K, B, and C. So I assume X is constant, correct?
So X is a variable in it. So X is the thing that you actually plug numbers in. So X is a value on the unit circle. It's like pi over 2 or pi or 3 pi over 2 or 4 pi over 3 or something like that. So X is actually the variable. All the other things are constants. Does that clarify that?
Yeah, thank you.
So in other words, like, let me just show a quick example then. Like down at the bottom of the page, these were a couple transformations we wrote out, and we plugged numbers into A, K, B, and C. We didn't plug anything into X. X is just a variable. Okay, so let me just show you the Desmos thing real quick. So what you should have done, I'm sharing my screen again, so you would want to look at that part. What you should have found when you went to graphing sine and cosine in Desmos, this is all from the video for the other day, is I'm going to turn sine off and just look at cosine. So this is the cosine graph. You should have seen that A, when you increase A, it controls vertical stretching and shrinking. And then when you make it negative, it actually flips it upside down. So that's what you should have found for A. B does horizontal shifting, right? So we're not stretching anything. We're just going side to side with that. C does vertical shifting, so up and down, not stretching. And then K does horizontal stretching and shrinking. And then when you make K negative, it flips it horizontally. And so this gives you a nice tool to sort of play around with things and sort of see what different transformations do. And then the idea is you should have filled this table in with that information. So A, B, K, and C do the things that I just said they do. And so that means that, now that we kind of know that A does vertical stretching, for example, in question 3, if we want it to be vertically stretched by a factor of 2, it says, well, that means we make A 2, right? And then after we learned that, like, K does horizontal flipping, if we want this thing to be flipped horizontally, we make K negative 1. And so that was sort of the idea behind the first page, was figuring out what A, K, B, and C do in terms of transformations, and then write down some simple transformations. Thoughts about that page at all before we go to the next one? I think the next one was the one that Cameron was asking about, but are there questions about anything I've said so far? I'm happy to clarify anything there. I think when I ask questions, I'm just going to wait like painfully long amount of time in case someone's typing something or is thinking or whatever. Remember, if you're trying to talk, you would need to unmute yourself in order to talk. Looks like everyone's muted yourself, so if you're trying to ask a question, you would need to unmute. Or you could type it. Okay, there's another question on that page. I will flip to the next page and just do the rundown there. So the next page was talking about and nailing down these new ideas of amplitude, period, and phase shift, and tying them in to the transformation. So I'm going to read what it says in each one of these boxes. So if you have that, that'd be helpful. But while I read it, I'm going to zoom out and talk about the picture. The picture illustrates what it says in those boxes. So what it says in the amplitude, it says it's the height of one of the peaks, or half the distance between the biggest and the smallest value. And so here we're being shown that each one of those things is the amplitude, because the entire height of the graph would be between my fingers. And so half of that would be one of those, which would be the amplitude. And so you can see it's like if we drew a line down the middle, it's like the height of one of the peaks. And so that's what the amplitude is. And so that's going to be controlled by a vertical stretch, right? And so that's why A is the thing that controls the amplitude, because we know A does vertical stretching. And so if we want to know the amplitude, we just take the absolute value of whatever A is. The period is how long it takes the graph to repeat itself. And so I've marked off one period here because you can see that this bowl shape repeats itself right here, right? So that would be another period. So every time the graph repeats itself, it's one period. And so if the graph like stretches or shrinks horizontally, that's going to change the size of the period. And so that's why K, which does stretching, horizontal stretching, that helps control the period. So, in normal sine or cosine, K is 1, which means that it would have a period of 2 pi over 1, which is 2 pi. And so we basically divide 2 pi by whatever K is to account for horizontal stretching or shrinking, which will change the size of the period. The last piece is the phase shift. And so it says right here, the phase shift is just any shift side to side in the graph. And so both the graphs of sine and cosine normally start at 0, right? If I pull out the first page, find that here. If we look at sine and cosine from that first page, both on the camera here, they both start at 0, right? Sine starts here at 0, and cosine also starts here at 0. Yeah, I realize my mic isn't great. I should have mentioned that. I think I just put a piece of paper on top of it, which might have been part of the problem. My computer doesn't have the best mic, and I did order an external mic to help with that. So Amazon is I think pretty backed up right now. So I ordered it last week, but it's not going to be here until next Monday. So, but I do have. I'm trying to take care of the. Anyway, what I was trying to say here was, and I'll try again. I think I put a piece of paper over the mic a second ago, so that might have messed it up. Please do let me know if it's just permanently bad. So anyway, phase shift is moving the graph side to side. And what I was saying is both sine and cosine usually start at 0. Right? If we look at this picture here, they both start at 0. And so any shift away from that is going to be a phase shift. And so we know that moving side to side is controlled by the B in the equation. That was from the last page. That's why the phase shift depends on whatever B is. And then the last part of this was the interval, the B plus 2 pi over K. This is sort of saying like normally we graph these things on 0 to 2 pi, right? That's the size of the unit circle. It starts at 0, ends at 2 pi. But any sort of shift side to side or horizontal stretching or shrinking is going to change those things. And so a shift side to side. I'm sorry.
That xy coordinate, so 0, 2 pi, the 0, x, 2 y, 2 pi would be 2 pi value.
These are t values. So it's the x that's right here, where you can think about it as it's a distance on the unit circle. Right. Oops, sorry. Let me zoom out. Forgot I was way zoomed in there. So these are distances on the unit circle, 0. Let me let that focus. These are distances on the unit circle. So it could be like pi over 4, 3 pi over 2, etc. Right? We start at 0, we end at 2 pi if we went all the way around the unit circle. And what I'm trying to say here is if we take this graph and we either shift it side to side or we stretch it in and out, then it's going to change the starting point and the ending point. And that's why this thing depends on both B and K, because B shifts it side to side and K might stretch it horizontally or shrink it horizontally. So we account for both those things when we consider the period that is being graphed on.
What you say is that we start at 0 and then we move 2 pi units, or what do you mean?
So, like what I'm saying here is in the normal graph of sine and cosine, which look like these, they start at 0. So this is one period, right? Like this is one period because the next period would do the same thing, and this is one period because the graph just like keeps going, right? So, like in other words, the piece that's being shown right here is just this piece, but it keeps going, right? And this piece that's being shown right here is just this piece, but it also keeps going. And the first period starts at 0 on both of them, and they both end at 2 pi, if you see that. Now that this ending point here is 2 pi. But those points are going to change if either of those graphs are shifted sideways or if they're stretched like this. If you do either one of those things, like side to side or stretch side to side, it's going to change either the starting points, 0, and or the ending point. And so all this thing on the next page is saying is if you want to figure out one interval of one period, you need to account for horizontal stretching and shifting.
That makes sense. But if I were to jump, if we were to jump to say question 6, the period interval is pi comma 3 pi over 2. What you're saying is that the period starts at the pi value and ends at 3 pi over 2, correct?
Right, yeah. So let's look at this one. Yeah, so this is saying in this particular problem, this is the formula. This is the transformation we're looking at here, right? So in terms of the period, there's a k value of 4 and there's a b value of pi. So this thing has been both horizontally shrunk and shifted. And so that's why when we account for the period interval, we need to account for both those things, again, the shift and the shrink. And so I just look at this equation, I write down the A, the B, the K, and the C, and then you can just plug them right in here, right? So the B becomes pi in both those cases, right? And then the K becomes 4. But when you make it a 4, it actually cancels with that one. Maybe I didn't write that out. Maybe that's the confusion here. So when you plug in K into this, it becomes 2 pi over 4, and then 2 and 4 reduces to pi over 2. That's why this is a pi over 2 there. Maybe that was a confusing thing. And let me just sort of finish that then. So this is saying because this thing shifted pi, the period starts at pi, and then it was also horizontally shrunk, and so we need to account for that by adding that shrinking to it. And so what I did here is I just added these two things together, found a common denominator so I can add them, and it becomes this. And so this interval, pi to 3 pi over 2, would be the size or the interval of one period of this transformation. Let me pause there and see if there are some questions about that.
My only confusion is when we read the equation, which be f of x equals 2 minus 3 sine and the rest of the parentheses. It's the value is to know what values for what. Like what's A, what's C, K.
Okay, yeah. So let's go back to the general form here. The general form says, let me try to put these both up on the page together. So this is the problem from this page. This is the general form from the previous page, right?
Like
so
when I was doing this, I was looking at it and I thought A was minus 3. Oh, never mind this.
Yes, A is minus 3. So A is whatever's multiplying sine. So A is minus 3. K is whatever is like inside sine multiplying the x. So K is whatever is multiplying the x, right? So that's why K was 4. B is whatever is being subtracted from x, so that's why B was pi, and not negative pi, right? So the negative sign is like part of this general formula, and so the B part is just pi. Not, it doesn't include the negative, in other words. And then the C is what's being added or subtracted from the function. That's why this one was a little tricky, because the C was like over here, but you could have moved this 2 and added it over on this side and it would be the same thing, right? That's why maybe that was the confusing thing about this, is like it was hard to realize that that was C, but C is whatever is just like being added. And so this is like a +2 being added. Did I clarify that?
Yeah, that makes sense now.
Other thoughts about that particular one? We can look at the picture in a second. But were there questions about what I've just said there, though? Okay, so basically what I'm trying to do is like show you different types of problems you might see. So one type of problem is like you're given the equation and then you're asked to identify A, C, K, and B and write down like the amplitude, period, phase shift, etc. The other type of question is just give you a picture and ask you to figure out what those things are just looking at the picture. And so here's a picture, right? And so I'm realizing that this bowl, this like U-shaped bowl thing, repeats itself over here. And so that's what made me realize that this is the size of one period, because this piece just repeats itself right here. And so the period starts at 0 and it ended at pi over 2. So that's how I got this right here. I'll kind of go up the list. This is a cosine graph. I know it's a cosine graph because it looks like a bowl, right? If I go back to the shape of cosine, cosine is the one that looks like a bowl, sine is the one that looks like a wave or whatever. And so that's why I know this is cosine. And cosine usually starts at 0, and this one starts at 0 too. And so this one didn't shift left or right. That's what I was trying to write here. Like the normal cosine looks like this, and this one also starts at 0, and so there's no phase shift on this one. The period itself, like I mentioned, starts here and ends here. And so it goes from 0 to pi over 2. Well, that's a distance of pi over 2. And so that would be, the period size is pi over 2. And then lastly, the amplitude we said was half of the entire height, right? And so if the entire height is this, then half of that would be the amplitude, which I'm showing in 2 pieces right there. And so it would either go from -1 to 1, which is a size of 2, or from 1 to 3, which is also a size of 2. Right? So both those cases, we see that the amplitude would be 2. Thoughts about that? Questions there at all? Yep.
Oh, good. You can hear me.
I can.
When it comes to graphing these, is the graph always going to be like a symmetrical in a way? Like since they're always it's repeating.
So they're always going to repeat. So they may not have symmetry if you shift them over, right? Like this one has symmetry with respect to the y-axis. Like if we folded this like this, it would line up. But if this one was shifted over a little bit, you wouldn't be able to do that anymore, right? And so they don't have symmetry in the sense of like by definition symmetry that we talked about in the symmetry section, but there'll always be symmetry in the sense that the same shape repeats itself over and over again. That's why when we graph these things, we really only care about graphing like one period. Because that shape, once you have one period, you can literally just copy that and paste it repeatedly and it'll just propagate the function. Does that sort of answer your question? Is that what you were sort of asking about? I think that was Sean.
Yes.
Okay,
Thank
great.
you.
Other thoughts about this page or what I said about this problem?
Our period for this problem makes sense because obviously it starts at 0. But what if the period doesn't start at 0? So say it starts at, I don't know, pi over 4. Pi over 2. What's our true distance?
Sure. So you cut off at the end, but I think you're sort of saying like, what if it was shifted over or something like that? What would the period look like? So let's just do a quick example of that. So I'm just going to graph, say, sine of x minus pi over, I think you said pi over 4. So let's do that. So this is just b is pi over 4 in this. And so this is just taking sine and shifting it to the right pi over 4. And so normally sine just does this. That's just normal sine of x. And so we're going to shift that, and usually starts at 2 pi and ends at 0, right? But now let's shift that to the right pi over 4. So instead of starting at 0, it's going to start at pi over 4. And instead of ending at 2 pi, it's going to end at 2 pi plus pi over 4. But it's going to be the exact same shape. So it's still going to go between like 1 and minus 1. Those are those levels right there. And so it's still going to do that same thing. It's just instead of starting here, it starts here. And so it'll look like this, something like that. I know it's not the best graph, but hopefully you can get the idea. And so this period then starts at pi over 4 and ends at this. And if we did that addition, that would be 8 pi over 4 plus pi over 4, which is 9 pi over 4. And so the period would be from pi over 4 to 9 pi over 4. Is that sort of what you're asking? And it would continue, right? I only drew one period, but this graph like continues in this direction. It would go like that forever. It continues in the other direction. But when we graph these things, we just focus in on one period, because since it just repeats itself, we don't need to draw a bunch of things, the same thing over and over. We just like focus on one period, and then we just know it continues in both directions. Not sure who asked that question, but does that clarify it? And can you see what I'm writing? It kind of looks very light on my screen. Are you able to see that?
As you said back to the page 52, you said that our period is the distance of pi over 2, which makes sense, obviously. My question was, what's the distance for like this graph? It doesn't start at 0 and doesn't end at whatever value. Like I said,
So it would be this, right? It starts at pi over 4 and it ends at 9 pi over 4. And that distance is still 2 pi. So we just shifted it over. And so the size of the period is going to be from 9 pi over 4 to pi over 4. How do we find that distance? Well, we could just subtract them, right? 9 pi over 4 minus pi over 4 is 8 pi over 4 pi. So we didn't change the size of the period. We just shifted it over so that it started and ended at a different spot. Now, what would change the size is if we put a k value, right? A k would go right here. And if we had a k value multiplying on the outside, that would stretch or shrink this, and then that would change the size of the period. Other questions about this? I can quickly just sort of mention the last page if there isn't another question. Okay, I'm going to go on to the last page. You're welcome to ask a question again, though. So the last page was just kind of putting it together and writing down some transformations, like identifying this one as b being -2 so that it moves left, identifying this one as k being 2 so that it's horizontal shrink, identifying this as being a being 2, which means it's a vertical stretch, and identifying this as c being 2, which means it's a vertical shift. And then once you know what's going on there, and if you know that's the normal graph, you can just do those transformations and sort of match them up to the correct values. And then the thing at the bottom is just a reference. Sometimes it's hard to show horizontal stretching or shrinking like I was just doing there. And so horizontal stretching or shrinking is doing this, right? That's why on this graph, the normal one is the black. And if we stretch or shrink that horizontally, the height doesn't change, right? And the starting point doesn't change necessarily, but the ending point might change. And that's different than shifting, right? So in this one, this one has b values that are non-zero. And so this is taking the blue line in both cases and shifting it left or right. So we're not stretching or shrinking, we're just shifting, which means it's the same exact shape, same exact period, just moved around. So this is just sort of, again, showing you visually horizontal stretching and All right. Thoughts about the notes at all? Anything on the notes that I can continue to clarify there? Let me double check the homework here. The homework for this, excuse me, isn't due until next Wednesday. And so it gives you some time for that, but don't wait too long. You don't want to forget this, basically, right? There's 2 homework assignments that are due on Wednesday that are things from before break, basically, that we kept putting off. And so there's a couple things due tomorrow night. Let me see how people have been working on those really quick. I just want to see if people have been working on them or not. Looks like most people haven't started that yet, or maybe about half the people have done it and half people haven't. So anyway, that's fine. You may have a hard time remembering it, but hey, you left it for 2 weeks, and I wish you the best on that. I'm happy to help, and there'll be tutors available to help as well. But try not to do that with this one, man. Don't wait that long to start working on this stuff. Must have been a nice 2 weeks off, I guess. Anyway, can I answer some other questions about this or the homework? We working on the homework? Any questions about the homework or anything we want to look at? Okay, if there isn't anything else, I'm going to sign off here. I'll remind you, I'm around generally most of the day. So if you're working on stuff, you want to, I have to pop back on here and like do a couple examples. If you have a question about something, shoot me a message and we can get back on. Thank you guys for coming. I will see you on Thursday. The video is already posted up there for Thursday. And I will see you around 11 o'clock. Thanks, guys.